Welcome back, Stats. Sorry I didn't post last week. The fiance and I actually have some exciting news. And so we have a new creature living in the house. His name is Benny, like Benny the Jet Rodriguez from The Sandlot. All of you remember, that's my favorite movie. Benny will be live this week with us during our session. So please, I'll see you there and you can meet him for the first time. Today, we're going to come back to the geometric and the binomial models. We're going to discuss the nuances behind them and how to think about them. Last week, we talked about it as a conceptual standpoint, kind of what is the difference and how can you think about the two differently. Today, we're going to look a little bit into the math and how do we actually determine something other than the expected value. Last week, we begun with the geometric model and discussed the pieces of it that you can think about in order to determine if a specific probability or if a specific Bernoulli trial is actually geometric in nature. To remind us, the question to ask is, how long does it take to reach our first success? On the other side, a binomial model, the question to ask is, how many successes are there in n trials? Now remember, n is a variable that we're going to use to dictate the number of trials that we have in a specific Bernoulli trial. Here are the two differences between the two questions you can ask. And in thinking about them, we didn't touch on the procedural piece of discovering how to use the equations that were given to you within the textbook, within the ebook. In a geometric model, we care when the first success happens. We want to know when that is going to happen. We don't want to know just if it happens. We need to know when it happens. So here, it's really important that we understand how many times do we need to fail in order for us to succeed for the first time. The equation that's given to us in the book is actually the following. The probability of x is equal to the number of times we fail multiplied with us succeeding for the first time. Now, let's talk about what I just wrote down because that's a little bit confusing to some of us. In this equation, x actually represents the number of trials until we get a success. So here we're interested in the fact, if we're going to be doing something, let's say I am shooting a basketball. If we wanted to say hypothetically, if Hernandez were to shoot a basketball, what are the odds that he makes it in for the first time on his 5th shot? X here would represent the 5 shots that I take. So here, X represents the number of trials until a success. So when we're taking notes, if a problem asks you to determine the probability of something happening after a certain amount of trials, you can consider that a geometric probability. Now, the confusing part of this whole equation is the exponent here. Why is it x minus 1? Why would it be my 5 shots minus 1? Well, if we think about it, if I wanted to take 5 basketball shots and I wanted to make my first one on the 5th time, I would need to miss 4. In this case, I would take my 5 shots, minus 1 because I am going to make it eventually. This would represent the 4 shots that I miss, and here's my 1 shot that I actually make. So this represents the number of times I fail, or the probability of me failing, x minus 1 times. The P, on the other hand, is me finally succeeding. My first success. In a geometric model, we don't have an exponent for P because we're only looking for our first success. We're only going to succeed one time after a certain amount of trials. However, we are going to be failing a lot more. Here, order tends to matter because we need to fail before we succeed. The binomial model is actually a little bit more challenging, so we're going to take a second to break it down before we can actually continue forward. In the ebook, the equation for a binomial model, the probability of x equals ncx, these are both subscripts, multiplied with the probability of success happening, x times, multiplied with us failing, n minus x times. This doesn't look as intuitive or as easy to understand as this guy over here. But don't worry, this is not as challenging. So let's break it apart into the different components. Remember, in a binomial model, we care about how many times we succeed within a certain amount of trials. So in that case, we need to know how many trials we're actually having. So n here represents the number of trials. The issue with this and how it differs with this guy is this x value. The x in the binomial model actually represents the number of successes. So these two models are a little bit different, and if you remember, the geometric, we care about how long does it take. We want to know how many trials until we succeed. The binomial model, we just want to know how many times we succeed. So here the x value will be a little bit different. N represents the number of trials, x represents the number of successes. In this model, we're going to hold off on the n choose x piece of it. Let's see if this makes sense to us. If I have p to the x power, that means that I'm succeeding x amount of times, which makes sense. If I'm shooting a basketball 5 times, what are the odds of me making 3 of them? I would do the probability of me making 1 multiplied by me making 2 multiplied by me making 3. Probability of me making a basketball 3 different times. Well, if I've only shot the basketball 5 times and I make 3, that means I have to miss 2. So this probability of failure, I'm going to call this one success and this one failure. If I succeed X amount of times, then I fail the rest of the time. This represents the probability of succeeding. This represents the probability of me failing. This ending piece of this equation that the book gives us looks very similar to the geometric. If I succeed a certain amount of times, I must fail the rest of the time. Now, this component, the n choose x, ncx, is actually the difficult part about this problem-solving process. N choose x. Given n trials, I'm going to put that up here, given n trials, I wrote it a little small, given n trials, we want to choose x amount of times that I succeed. The number of successes. This little piece, n choose x, which means if I shoot a basketball 5 times and I want to make 3 of them, I can make any combination of that. So what this does is it actually eliminates the order, such that the order of successes doesn't matter. Because I could shoot a basketball and I can make any of those 5 shots. I can make the first 3, I can make the last 3, I could do a combination of them. So here, this allows us to explore me succeeding in every possible way. The geometric, on the other hand, I need to fail every time before I can actually succeed. So I'm going to erase the board and I'm going to talk about how can we find this piece on a calculator? How can we do the math in order to solve for this? Here I rewrote the equation for us. We're talking about the binomial model and we're going to be focusing on this piece here. N choose X is how you can say it. What essentially this piece of the equation does is it allows us to see any order of success. As previously stated, I wanted to talk about me shooting a basketball. If I shot a basketball 5 times and I wanted to choose 2 of those 5 times in order to make the basket, I would succeed twice and I would fail the rest of the time. But because order doesn't matter here, we can actually look at this equation, or this piece of the equation, to help us mix and match the different opportunities. Now, if I had you do this by hand, as in a previous unit, you would write down all of the probabilities for each thing occurring, and then you would add them all up to receive your final probability. Here, this small piece of the equation does all of that math for us before we actually start multiplying through what it is we're actually doing. So let's talk about N choose X. N choose X actually has its own equation. It's not too difficult to go through, but let's look at it here. We have N choose X, which means we have a certain amount of trials and we want to just choose a couple of them to be successes in any order. In order to find that, we're actually going to take the number of trials that we have, factorial, an exclamation point. It's not that I'm excited for the trials, it's called the factorial. I'll explain that in a little bit. Divided by x factorial, which is the number of times I succeed, multiplied with n minus x factorial. This equation, while it looks complicated, actually lets us explore the different ways of organizing the combinations of successes in a given trial. This equation lets us discover how many combinations of successes, which we denoted as x here, how many times, how many successes are found in n trials. So this equation actually lets us look at how many combinations of these successes that we have. Remember, x in this case is the number of times we are going to succeed. P is the probability of us actually succeeding. So this shows us how many different combinations are there for me to make a basket out of 5 trials. If I wanted to make it 3 different times, there's plenty of different combinations for that. So with this said, you can actually rewrite this equation if you'd like and turn it into the probability of x equals, I'm going to put a bracket here, n factorial divided by x factorial over n minus x factorial multiplied with the probability of succeeding x amount of times and the probability of me failing the rest of the time. Now, for the sake of this video, I'm going to end it there, strictly to notes on the differences between the two in terms of a procedural understanding. Check out the second video coming out for the answers of the homework assignments that we have. This stuff I'm not going to be explaining through the homework assignment. I'm going to be showing you how to do the math. So hopefully this video serves as a purpose for you in order to better understand the differences between performing operations with the geometric model and the operations with the binomial model. So I'll see you then. See you Monday and Wednesday.